This next topic, I just put one example. They all look like this. So this will be when you have an absolute value equal to an absolute value. And, step number one, isolate your absolute value. Well, you've got one on each side. Great. Step number two, solve it once equal to the positive and once equal to the negative. What does that mean? Well, it means that we're going to start by just taking off the absolute value signs. We're going to solve where 4x minus 1 equals 3x plus 5. If we solve this one, we would get the x's on one side. So I'm going to minus 3x from both sides, and I get x minus 1 is equal to 5. And then I'm going to add 1 to each side, and I end up with x is equal to 6. And before we go and solve it again, let's just look to see what this means. This means that if I plug in x is equal to 6, left side will equal right side. So if I check, I'm going to end up with the absolute value of 4 times 6 minus 1. Does that equal the absolute value of 3 times 6 plus 5? And what do I get? Well, this is going to give me the absolute value of 24 minus 1, which is the absolute value of 23, which is 23. Cool. Okay, on the right-hand side, remember, because we always draw a line down when we're checking, I've got the absolute value of 18 plus 5, which is the absolute value of 23. Oh, look at that. It's also 23. Cool. So it made left side equal to right side. In fact, even without the absolute value brackets, left side was equal to right side. So what's the second one going to do? Well, the second one, we're going to set it so that 4x minus 1 is equal to negative 3x plus 5. So we're going to switch all of the signs on one side of the equation, right? It doesn't actually matter if you make it equal to negative on the left side or the right side, but only one side. So we're going to be solving where 4x minus 1 equals negative 3x minus 5. We're going to make these absolute opposites from each other. Now when I go to solve this, I'm going to add 3x to each side. I end up with 7x minus 1 is equal to negative 5. I'm going to add 1 to each side. I'm going to end up with 7x is equal to negative 4. And I'm going to divide both sides by 7, and I get x is equal to negative 4 sevenths. Not every answer is pretty. Okay, and now we're going to check this and we're going to see what happens. Like, why does this work? If I check it again into the original, I've got 4 times negative 4 sevenths minus 1. Does that equal the absolute value of 3 times negative 4 sevenths? It doesn't look like a 4, does it? Plus 5. Okay, now these ones I'm going to recommend we use a calculator. So I'm going to split my screen. And I'm going to plug it in as I see it. So on the left-hand side, now you can't put absolute value brackets into your calculator, but I can plug in 4 times negative 4 divided by 7 minus 1. So you're going to plug it in just as I said. So 4 times negative 4 divided by 7 minus 1, because I really want to enforce that, I've kind of been checking these by hand as we go, but I'm actually inherently lazy. I use my calculators for checks all the time. I don't show these steps. Like in here, I'm like, okay, 4 times 6 is 24, minus 1 is 23. But really, I would just go 4 times 6 minus 1 in my calculator or on my head, and I would get straight to 23. But as soon as I hit a question like this, I'm definitely using a calculator. Like, I'm not going to go through and make this over 1 and multiply across and then get a common denominator. It's too much work, right? So I want you to make checks quick. So on the left-hand side, I have the absolute value of this gross decimal, negative 3.2857 dot dot dot. And when I take the absolute value, it's going to come out to positive 3.2857 dot dot dot. On the right-hand side, if I plug this into my calculator, I've got 3, oh, not 3 times. Oh yeah, 3 times, right, I'm doing the left-hand, the right-hand side. 3 times negative 4 divided by 7 plus 5. Oh, look, I got the same gross decimal, but this time I got it as positive. So I got positive 3.2857. So what happens is now when I take the absolute value, it stays positive. But can you see how this worked? So when I solved it once with them equal, I found the value of x that would make both sides the same, either both negative or both positive, but absolutely the same. Whereas when I solved it again with opposite signs, I said, hey, what would make left side equal to right side, but with opposite signs, one being positive and one being negative? Because I'm solving an absolute value equation, and even if one's negative and one's positive, they're equal because the absolute values will make them positive. So I only showed one example of this, but there are 3 questions again that you can practice in your textbook. Have fun.